going to do this problem. Minimum remove to make valid parentheses. Given a string only contain left and right parentheses and lowercase English letters. The task is to remove the minimum number of parentheses so that the result string is a valid string. How to define a valid string is like this one. If they're empty and they're only lowercase, also it can be returned as AB, A concatenated with B, where A and B are valid string, or it can be returned as parentheses outside the A, and A is a valid string. Let's take a look at the example. So like this one, the output will be we remove what we removed. We removed one right parenthesis and make it valid. Here, how to remove? We also remove the first right, and in this case, we need to remove everything to get the valid parentheses. So, and some assumption or constraints. Length will be like this one, this length, and the input will only be left, right, and lowercase English letter. The goal is we need to remove something to make the string be valid. There can be two approaches. First, to remove all valid or invalid right parentheses from left to right, then from right to left to remove all the invalid left parentheses. This is one approach, and the other one is one scan from left to right to identify which parentheses is not need and put them into a set, recording the index. We don't want that part. After that, we iterate the input string to only consider the necessary one, not the remove all the invalid index of the parentheses. The second approach seems more intuitive, so let's do that one. The goal is to have a set or the no need invalid index. We start to moving from the first index. We also need a stack to help us to check if everything is valid. So the stack, okay, if the chart is left one, we directly push to the stack. Append all for last. Else if the try is the right one. Let's say if the stack is not empty and the stack, the peak Pick last is this one. This one, so which means we in this case we need to remove that. So now we have a left one. We directly input offer into our stack. If we are encountering a right one, and the previous one is still a left, it's a left one. We are encountering a right one, and the previous one is a left one, such that in this case, which means they both are valid. We are not. It's valid, so we are to remove the last one. Else, if not this case, which means we need to remove this index. Also, there's another chance the thing is character, so in that one we do nothing. I think it's okay for us. Now we are trying to build the final answer. Go through all the index. If it's not inside contains this index, we are continue. Otherwise, we append the character at this position. At the end, we return the string format about our final answer. Okay, let me run to verify if it's okay. So the first two cases passed. The last one, we should remove everything. So why it will be happen? This case it's left, and I will push into two index into the stack. Let's check the stack inside. It will 1 and 2, 0 and 1. Then oh no, we encounter the right one. If it's not empty, so which means the invalid, we already encounter invalid, and they have the 1 and the 0 and 1 here. Now we go to the left part. Go to the left part. They also inside the stack. So the stack, inside the stack, they have these two. Eventually, they should balance, right? So I need to add this thing while the stack is not empty. We need to push everything into the in-stack values. Go this way. These two index will also go into this invalid one. After that, we will have stack. Oh, by the way, it's recording the index, not the stack. Return I if it's pick. Okay. Alright. the purpose of this one, the stack, is to so what's the type I should to store inside this stack? Should be the index. Left one, and I definitely know this always be the left part. And if it's not empty, and it will always be the left. So now if I pick last, I will need to see the chart at that position is left or not. If the previous one is left, it's the left parenthesis, and it will match our conclusion here. If the previous one is still the right one, we need also to remove that one. So we need to check the previous one in the stack, it's left or right. In that thing, we can get the right previous one characters. That's right. And submit. Yes, it goes through. So the time complexity will be we go through every position once, and in the iteration inside this for loop, everything is constant time. We only append at the end and pull out of the end. So the overall time complexity will be O(n). The space, we have two additional data structure here, so the space will be also O(n). Yeah, I think that's it.